Section 2.8 has to do with inequalities on a number line and solving absolute value equations. So there's a couple of vocabulary words I want to go over. The first one is compound inequalities. That's a statement made up of more than one inequality. Now we did problems like this earlier in the year and graphed those, but now we're going to have more than one inequality. We're also going to be working with absolute value, and absolute value is the distance x is away from 0 on the number line. It's represented by two vertical bars. Okay, now we're going to change this problem here, the absolute value. We're going to put the absolute value sign around the x. So we're going to graph the absolute value of x equals 2. Well, what values can we put inside there? We know that if we put 2 in there, that's okay. So we're going to put a point at 2. And then we're also going to use negative 2 because absolute value is the distance away from 0 on a number line. So we're 2 units this way, but we're also 2 units this way. So we can have 2 or negative 2 to make that a true statement. So we're going to cross that part off. Okay. To graph compound inequalities on a number line, we have to first decide when a compound inequality contains the word or, at least one of the parts or statement has to be true. When a compound inequality contains the word and, both parts of the statement must be true. So let's look at a couple of examples here. We're going to solve and graph these compound inequalities. So this says or. So one or the other has to be true. I'm going to just pretend I have this as a problem and then this as a problem. So I'm going to add 2 to both sides, and that's going to give me x is less than 3. So let's go ahead and graph that on the number line. Now from before, we're going to go to the number 3 as my endpoint open or close. Because it's less than, it's going to be open. And if x is on the left-hand side, this inequality is pointing in the direction that your arrow needs to go. Less than also is to the left. The numbers are getting smaller. Okay, so we took care of that one. Now we're going to solve this one. We're going to divide both sides by 5. And we have x is greater than or equal to 6. Now this has a line under here, so that means the endpoint is closed. And it says greater. Numbers get greater when we point to the right. So either one of these has to be true. So all of the numbers to the left, excluding 3, and all of the numbers to the right, including 6, will work in this inequality and that inequality. All right, here's another one. We're going to divide both sides by 2. And we have x is greater than or equal to negative 3. And so this means both have to be true. So we're looking for an overlap. All right, now when we divide this by negative 1, the inequality flips, so it's going to be x is less than 4. All right, so we have greater than or equal to negative 3, so let's do that one. And less than 4, so open circle going to the left. Okay, now you have to pay close attention to these words, and or and and. And means both have to be true. So a number has to be greater than negative 3, and at the same time, it has to be less than 4. So the only numbers that will work are where there's an overlap. So just these values right here. So what I'm going to do is I'm going to cross off this, and I'm only looking for the overlap. So let's just regraph it down here. Oops. If we regraph it down here, we're going to get, here's a negative 3, here's a 4, and we're just going to graph it like this. Any numbers that are greater than negative 3 and less than 4. So only these values will work in both of those inequalities. All right, now we're going to solve absolute value equations. Since the value of the expression inside the absolute value sign could be positive or negative, so think back up here when we did this example, it could have been a positive 2 or a negative 2. When solving absolute value equations, you must set up two equations. Always get the absolute value sign by itself first. Okay, here our absolute value sign is already by itself. So what I want you to do is, this will be a true statement if this value is equal to 5, or if this value is equal to negative 5. So we have to find both of them. So we'll add 7 to both sides, and we have x equals 12. And here we'll add 7 to both sides, and we have x equals 2. Okay, here my absolute value sign is not by itself. So I want that by itself, which means I have to subtract 5 from both sides, and I end up with 3x equals 9. Okay, now from here, for the absolute value of 3x equals 9. So let's just rewrite it over here because I'm running out of space. Okay, so this value inside here could either equal 9 or it could equal negative 9. So let's find out what both of those values are. So 3x equals 9 or 3x equals negative 9. We're going to divide both sides by 3. And so we get x equals 3 or x equals negative 3. Those are our two answers. So you should have two answers for each question when it's absolute value. Okay, you have a few, you try it.